All right, guys. Hello. I hope you had a great weekend. And just briefly, let's review what we covered during the last lecture. So we wanted to investigate the properties of variance. We know that expected value of a sum of random variables is the sum of expected values, correct? And that happens no matter what those variables, how they are related. They can be dependent, independent, weakly, or strongly. That doesn't matter. When is variance of, let's just see, guys, if you remember, variance of the sum of x1 through xn, under which condition will it equal to variance x1 plus variance x2 plus variance and onwards? Could you remind me, please, if you remember? What's the condition? All right, great. We established that we don't remember. Okay, Jack, you are correct. Jack does. When they are independent, that's the only way that happens to be true. Okay, so how do we verify that? We first created covariance. And covariance is an extension of variance. You see, given two random variables, x and y, covariance is defined as the expected value of x minus mu x, y minus mu y. Remember that, guys? And by carrying out calculations, we see that covariance of xy happens to be the expected value of x times y minus the expected value of x times the expected value of y. Now, you might be aware that covariance is related to correlation, guys. So covariance could be negative, it could be positive, and it could be zero. Okay, so we had verified a bunch of properties, which I hope you understood how we were able to do that. So for instance, covariance of xy is the same as covariance yx. That follows immediately because x minus mu x times y minus mu y is the same as multiplying the variables in reverse. Yes, so that is easy to see. And covariance of x with x, that's the definition of variance. It's just when you take x minus mu x squared. Covariance is linear when we fix one of the variables. Either fix the first or second variable and you will find that covariance is linear. That's statement C and D. They explain that. And so here we just established why that is true, and then we observed that covariance of a sum of random variables with another sum of random variables, it's covariance of any combination of two variables from first entry and the second entry, right? So in this case, it's the sum of covariance. It's the sum of covariances where I combine x's with y's, any combination, which I can then separate into combinations having if let's say I calculate variance of the summation, that's covariance of the summation of x against another summation of the x's, and I can group by the moments when the x's match. Let's say x1 against x1, x2 against x2, x3 against x3. Yes, and that will generate, there will be n such matches, right? Because we have variable 1 through variable n. So it will be the sum of the variances plus the summation of any other encounter where it's a heterogeneous encounter, right? So this summation is what? You can imagine, let me just maybe show you with my drawings here. So it's a heterogeneous summation where, for instance, if you have covariance of, let's say, x1 plus x2 plus x3, let's do it with 3. And let's draw the other one, x1 plus x2 plus x3. So this is variance, right? This is variance of x1 plus x2 plus x3. Yes. Now, what is the result? What is the situation, guys? We can have a combination of x1 with x1, of x2 with x2, and of x3 with x3. Yes. So that's where, when I combine, I generate then variance of x1 plus variance of x2 plus variance of x3. Now, the other possibilities are what? So we can have, for instance, covariance, and I will draw it, let's say x1 with, we just have this combined with x2, right? Plus covariance of x1 with x3. And those are all the combinations of x1. Then we also have plus covariance of x2 with x1 and x2 with x3. And then, of course, we have covariance of x3 with x1 and covariance of x3 with with x2. Those are all the combinations possible. Do you agree? I listed all the combinations possible. Now, do you see, guys, that they come in pairs? Let's say we have x1 and x2. We have one case where x1 is black and x2 is red. And we also have the situation where it's reversed, right? So where we have, let's say, here is x2 and x1. Do you see? Those two are very similar. They are the same. So this and that are the same. They come in pairs. We also have that this x1 and x3 is x3 and x1 are the same. And the remaining ones are the same. Good? So what's the situation then is simply, you can always double and say that the first one is smaller than the second. Right? So it's really, the formula essentially is what? So a variance of the summation from k equal 1 to n of xk will be the summation of the variances of the xk plus 2 times the summation. Here we have k equal 1, and here we have j is bigger than k, right? All the way to, so we have here covariance of xk xj, right? Where k goes from 1 to and minus 1. So we have this, this formula. We can always ensure that j is bigger than k by just rearranging and multiplying by 2. Good. So we notice, guys, that if x and y are independent, however, then the formula becomes just as we hoped. It's just the variance of the sum is the sum of variances. But that's only when you have independence. Why is that the situation? Is because when x and y are independent, if x and y are independent, then covariance of xy has to be equal to 0. Why that follows? Well, let's look, guys. I hope you understood what I tried to explain, how you can calculate expected value, guys. It's all very, very easy as long as you understand it's just rearrangement of additions, right? You understood that the expected value, you can use the sample space to calculate it, or you can group it by the combinations of variables. So the only issue in calculating the covariance of x and y is in calculating the expected value of x times y. Now, the expected value of x times y can be written in this form. It's the summation over all the values that x can take, combined with all the values that y can take, multiplied by the probabilities that x is one value and y is another value. You understand? I can always make that representation, insisting that the probability x equal to xi and y equals to yj is equal to 0 in case the combination is not possible. You understand? So I can always imagine multiplying every value that x can take with every value that y can take times the probability of this combination. Good? So if the variables x and y are independent, then this is an intersection. Probability of x equal to xi, y is equal to yj is the product of the probabilities. Please confirm that you understand and I'm not just talking to myself or to the echo. Can you hear me well? The echo bothers you? Jennifer, yes, it bothers you, the echo, or yes, you understand. So write yes that you understand if you can split. Good. So what about the rest of you guys? I don't see a lot of understanding. Yes? So this is a product of probabilities, guys. Now, do you recognize that this summation so okay, thank you, Sarah. So you see this probability. If x and y are independent, the probability that x is equal to xk and y equals to yj is the product of probabilities, right? If x and y are independent, then of course each value that x can take, it can still take those values no matter what y did. Do you agree? You understand, guys, right? So all the combinations must be possible. That's of course just one aspect that you have to notice. The other is of course that the probability of an intersection here, x equals to xi and y equals to yj. That's the intersection of events. That must be equal to probability that x is equal to xi multiplied by probability y equals to yj. That's independence. Everybody understands that. Very important. Right? No need to be shy. If you do not, just let me know. So we have this, and now final thing, guys. Look at this expression. This is just what happens when you FOIL a product. Do you see what this is meaning? This is a summation over all I and over all j. Right? So I can factor it out. Do you understand what I do, guys? I just recognize multiplication. If you want multiply addition in one parenthesis by addition in another parenthesis, when you FOIL it, I think that's what you call it, the result will be that each term from one parenthesis will be combined once with each term from the second parenthesis. They mix like this. So I just look at it and I say, oh, that's now exactly just a mixture, right? So I can take x, p of xi, I can separate it as a sum from a y, p of y, j. And that becomes expected value of x times the expected value of y, which now, because my covariance, you remember, covariance is expected value of xy minus expected value x and y, that is 0. Now, yes. By the way, covariance, and that's completely nonsense to you, I guess, but to me, kavarny is bloodthirsty. So covariance, it reminds me of how bloodthirsty I am. It means sneaky, it means, you know. By the way, before I begin my thorough investigation, if you placed, if you decided to copy on the exam, you might better admit it. If I catch you, there will be no mercy, as I wrote it over there. All right. There are 5 fair coins. Remember, we actually even did this problem to a point. We verified what's expected value of x and what's the expected value of y. So x here is what happens, what's the expected value if for the number of the coin that we picked. And y is the expected number of heads. You see, y is 0 if tails and 1 is heads. Right? So we take one of the 5 coins randomly and we toss that coin and we see whether we get heads or tails, and we want to know what's the expected value. 1 is heads, 0 is tails. So expected value of x we verified to be 3. Remember? We just take expected value of x is which coin number is picked multiplied by the probability, and that just happens to be 3. Expected value of y is, we concluded that it is 0. Notice in this calculation, I already assumed that I don't need to care about which coin I picked, but that's only because it's equally likely I pick any coin, and within this coin, there is no influence on whether it's heads or tails. So the expected value of y is 1/2. Variance of x and variance of y, what are those? So the expected value of x squared is k squared times 1/5. It's the expected value of x squared, which is 11. So variance of x is 11 minus 9, which is 2. Similarly, the expected value of y squared is 1/2 still, and so the variance of y is 1/4. Yes? Now, before I do anything else, guys, could you tell me what is the covariance of x and y? Yes, Sarah, but that already implies that you already know what's the variance of x and y. So I asked one question slightly before, but that's good. All right. Guys, the simplest thing to do is not to calculate here. Just think about it. If you were to know which coin was picked, let's say coin 1, will it influence the likelihood of scoring heads or scoring tails? Because each of those coins are fair, it will not influence. Yes? And that means that the random variables are independent, which means that the covariance is 0. In this particular situation, covariance is 0. And therefore, variance of x plus y is the variance of x plus the variance of y, which we calculated. Variance of x is 2, variance of y is 1/4, so it's 9/4. Here is another question, guys. Let's do that together. See if you can do that fast. So 2 fair dice rolled. Compute variance of the sum. Okay. In other words, I want to know how, from on average, from game to game, is the sum going to vary from one value to another, from the average, so to speak, right? So we need to know what's the average that you get per game, and how much do we deviate from the average. We're calculating the variance, right? So you can calculate anything else that you find useful for that calculation, Jennifer. We're calculating the variance of the dice, of the sum. Okay. All right, so I suppose 3 people have calculated it. Let's see how that's done. Well, I mean, I hope you calculated it. So what is, first of all, we have X value on die 1 and Y value on die 2, yes? So then we want to calculate first the expected value of X plus Y, which we know is the expected value of X plus the expected value of Y, which is twice, because they are the same variables, they are identically distributed, it's twice the expected value of X, which is equal to twice 1/6 k equal 1 to 6 of k, which is twice times 1/6 times 6 times 7/2. Yes? So the answer is that the average is 7. You understood what we calculated? X plus Y is the average on those dice. So in other words, if we play this, if we toss 2 fair dice many times, we will observe that on average we get 7 per game. Yes, 7. The number 7 on average is what comes up per game. Now I want to. I now see that the dice are fair, which means that they are also independent of one another. So we have that variance of X plus Y is the variance of X plus the variance of Y, which is twice variance X, since again they are identically distributed. Yes? So how do we calculate the variance of X? So we need to calculate the expected value of X squared, and that would be 1/6 summation k equal 1 to n to 6 of k squared, and that will be 1/6. Here we will have 6, 7, and I believe 13, am I right? Over 6. Correct, guys? If I remember the formula correctly, right? I think it's 2n plus 1, if I'm not mistaken. So for the summation. So what do we get? We get 7 times 13 over 6. So then we take variance of X is the expected value of X squared minus the expected value of X squared, which is 7 times 13 over 6 minus 7 squared, right? So what's that? This is just 7 times 13 over 6 minus yeah. You are right. Thank you, Jack, for correcting me. Not to forget, it's 7 over 2 for one die. I forgot that the sum is 7, but right. So it's 7 squared over 4. So that would be 13 over 6 minus 7 over 4, and yeah. So you understand, that's pretty much, that's the variance of X, so just multiply it by 2. So variance of X plus Y is 7 times 13 over 3 minus 7 over 2. And so what you get is 7 times 26 minus 21 over 6. And that's just 7 times 5, which is 35 over 6, as you solved correctly. Good? So the answer is 35 over 6. Correct. All right, guys, here is another example. Help me. Each of n gentlemen will pick one of n hats at random. What is the expected number of gentlemen that pick their own hat? And what's the variance? All right. You understand, guys? So n gentlemen and hats, each picks hat at random. What is the expected value and variance of hats picked? In other words, what's the average of hats that will be picked that are their own? You understand my question? Yes? So how many of the gentlemen will pick their own hat on average, and with what variance? In other words, how much would it generally from game to game deviate from the average? Well, let's begin with the expected value, guys. So first stage is I need to figure out how to encode this information. So a very nice way to do that is we have gentleman 1 all the way to gentleman n. And we would say, so that's my variable x, and I would say that xk is equal to 1 if gent k picks on hat and 0 otherwise. Yes, you see what I did, guys? So that will allow me to very easily calculate the expected value. So what is that? The expected value of x is the summation of the expected values of the xk. And that summation is what? So what's the expected value of xk? What's the probability that, well, so obviously each person, I mean, there is symmetry going on here, right? The expected value x1 and x2 and x3, all of them have the same expected value. So I might as well say that this is n multiplied by the expected value of x1. Everybody agrees? Now, what's the expected value of x1? So it is simply 1. So it's n, 1 times the probability that he picks his own hat. Now, if you follow me, guys, what do I multiply 1 by? 1 multiplied by what number? Yes, 1 over n. Because, guys, I can ignore the others, right? If there is no preference. It's basically when it's randomly done, if each of them picks a hat randomly, then there is no preference to the hat that is allocated to person number 1. It is either hat 1 or 2 or 3, or there is no preference. Only one of them is his own hat, so it's 1 out of n. Plus 0, we get a score 0 times any other hat that he can get. So the answer is simply 1. The expected value is 1. No matter how many people we have, on average, only one person will pick his hat. Isn't it interesting? You can have you can have 5 people or 1,000,000 people, and on average, one person will pick the hat that belongs to him. Now let's try to calculate the variance, guys. So in this case, let me just ask you, are the xk dependent or independent? x1, x2, x3, are they dependent or not? Yes, Sarah, correct. They are clearly dependent, guys, because if person 1 picks hat number 2, person 2 cannot pick his own hat. So the action of any one of them influences the action of the other. So they are not independent variables. So we don't have a very nice formula. But we do have this, right? So the variance of x is the summation of the variances of x, okay, plus the summation of covariance. You agree? Now, guys, comes the crucial step. You see that I compare always pairwise. I compare xi with xj, right? So first of all, the variances here, the variances I'm adding up are the same number. You agree? Because variance of x1 should be the same as variance of x2. They are distributed identically. We are dealing with twins for this problem. Yes? So we see definitely that we have, this is the same as n multiplied by the variance of x1 plus a summation where I is not equal to j covariance xi xj. Now I can still write it even further. I can write it as n variance x1 plus here I'm going to write covariance, because comparing I with j is the same as comparing person 1 with person 2, for instance. Do you agree? Covariance x1, x2. Now, how many terms in the summation, please? The summation I not equal to j, I replace the term added by covariance x1, x2. How many terms do I add? N minus 1 factorial, and choose 2. Well, okay, we're getting, well, none of the answers are exactly right, but one answer is close to be right. Notice, guys, what happens here. We are picking, we're having any combination, xi with xj, correct? Yes, times 2, because we have encounter xi encounters xj twice, right? One x1 here and x2 here, or x2 and x1. You see? So that's true for all of them. So it's n choose 2 times 2. Yes? So what we have is simply n variance x1 plus n minus 1 covariance. Are you with me, guys? Do you understand how I got the n choose 2? Yeah? We have, they are identically distributed. We have each of them matched with each. So how many terms do we add? If the matching was once, I can say n choose 2. But because the matching is doubled, it's multiplied by 2. You see, it's x1 first, x2 second, or x2 first, x1 second. I hope you see that. Now let's begin calculating each term. What is the variance of x1? So we have that variance of x1 is the expected value of x1 squared minus the expected value of x1, the expected value itself being squared. So what's the expected value of x1 squared, please? Calculate it. And tell me what it is equal to. Expected value of x1 squared, please calculate. Come on, guys, why so long for this one? Then if it's so long, you should afterwards discuss this material, because it means that maybe you don't know it. Okay, guys, because expected value of x1 squared takes a second to calculate. If you understand how. Okay, I'm still not, I'm trying to be, so maybe there is a right answer there, maybe not. I just want to see more people responding. Let's see. All right. Here is what it is, guys. What is x1 squared? It's equal to 1 if x1 is equal to 1 and 0 otherwise. Right? So what's the probability that it equals to 1? It's just the expected value of x1 squared is 1 multiplied, it's 1 squared if you prefer, multiplied by 1 over n. And therefore the answer is 1 over n. It's exactly the same as the expected value of x1. Yes? Yes. Guys, you are living the class. I mean, I think they understand everything very well. No, if you don't get this thing, then you don't understand it well. Then you stay after class and discuss this material with me. That's what I'm here for. Right? It's 1 over n right away. Do you see that? Because what do? You just take the score multiplied by the probability that the score can still only equal 1 or 0. It's just, it's distributed identically. x1 squared is x1. There's no difference there, right? The variable x1 squared is the same as the variable x1. There is no difference. Square doesn't do anything, because you square 0, you get 0. You square 1, you get 1. It doesn't change the variable. Do you understand that this variable is the same exact variable as x1, right? But now variance of x1 is the expected value of x1 squared minus the expected value of x1, where this number is squared. So it is 1 over n minus 1 over n squared, which, if you prefer, you can write as 1 over n, 1 minus 1 over n. Agreed? Yes? Wonderful. Not 1 over n squared, 1 over n. Okay, so look what we have here. We multiplied by n, right? So first part becomes what? It becomes simply 1 minus 1 over n. Do you agree? Because we multiply by n. It's 1 minus 1 over n. Now we need to deal with covariance. Now let's calculate covariance, guys. I want to calculate covariance of x1 and x2. What do I need to do? I need to calculate the expected value of x1, x2. and subtract the expected values of each individually. Yes? What's the expected value of x1, x2? In other words, what values can those take? And anyhow, let me not just mention too much. Calculate the expected value of x1 times x2. Okay, interesting, Jennifer. All right, we have so far 3 answers. What about more? All right, so you agree, those that wrote something, they agree that the answer is 1 over n minus 1, apparently. Yes? Now, why is, well, let's see if that's true or not, guys. So the only way they can equal to 1, right? So it's basically, it's 1 times the probability that x1 equals to 1 and the probability that x2 equals to 1. Agree? Now, that is the same as 1 times the probability that x1 equals to 1 times the probability that x2 equal to 1, given that x1 is equal to 1. Agreed? Now, what's probability that x1 is equal to 1 by itself? It means, what's the probability person number 1 picks his own hat? It's 1 times 1 over n. Do you agree? Times, what's the probability that x2 picks his own hat, given that the first person picked his own hat? So there are n minus 1 possibilities, yes? And one of those possibilities means that person number 2 picks his own hat, so it's 1 over n minus 1. And congratulations, you are correct, guys. The answer is, those that answered, it's 1 over n minus 1. I hope you understand it, right? I mean, you didn't look into my notes, correct? You just thought about it and you understood why. Beautiful, right? If you understand it. So it's just conditional probability. You see, once you get comfortable with it, it's not a lot of ideas. Sometimes I think, what am I teaching you? There's no information at all, right? It's just so simple. So, and yet people are disappearing. I guess they think, oh, same old, same old. I started with 30 something students and now it's 26, right? All right, so what happens then in the situation? We already kind of have all the information we need. Here is that expected value. Here is the 1 minus 1 over n. And when we multiply, you see we have 1 over n minus, this thing minus 1 over n squared. When I simplify it, what do I observe? Look at it, guys. Everything crosses out, and I observe that the variance is equal to 1 as well. Is it interesting? So on average, the deviation will be +1. You see, the difference will be +1 on average. So you would see some variation, like maybe 1 or maybe 2. That's the on average, right? On average, difference from game to game is 1 unit. All right. I just covered 5, yes? Or not? Yes, 5. Okay, then we are at 6. All right, guys, wonderful. We are now going to talk about binomial random variables. So this is a very important distribution. And the idea is, let's suppose we perform n independent trials, and each trial has some probability of success p and failure with probability 1 minus p. X will be denoting the number of successes. So we can have either 0 or 1 or all the way to n successes. And then we will know, of course, that the probability that I have k successes is n choose k times p to the k 1 minus p to the power of n minus k. Do you see where the n choose k comes from? The n choose k represents which particular successes we shall see, right? Or which trials produce success. My God, I lost another person. What am I? So, for instance, suppose that we have 4 independent trials to be performed, and we want to know what's the probability of getting exactly 2 successes. So those are the situations, right? So if x is equal to 2, if I have 2 successes, then the successes happened either at positions 1 and 2, or maybe position 1 and 3, or 1 and 4, or you can see that there are altogether 6 possibilities. We see where they're at, which particular trials produce the success. That's where I have n choose k. And I multiply the probabilities of success and failure because those are independent from one another. Agreed? So why is it p to the k? Because I had k successes and 1 minus p to the n minus k because the rest were failures. Right? So whichever particular situation happened, in other words, I try to kind of show you how the multiplication is done. So for example, if probability of success is 1/3, so here I had 2 successes. So success on the first trial, failure, failure, success. You see, this is the product. And for other arrangements, the product is different, but I can always group together successes and failures, right? Because the number itself, the product itself, is going to be the same as 1/3 to the power 2 times 2/3 to the power 2 in this case. Right, and then the 6 is 4 choose 2. Out of 4, which particular pair gives the success? Everybody is clear? Of course, we expect that the sum of the probabilities is equal to 1, which is always true for random variables. If I accounted for every possibility, the sum of the outcomes of the random variable, the sum of the probabilities of all the outcomes of a random variable must sum to 1. So what is it in this situation? So in this situation, it is, I can just calculate it algebraically, even if I want to verify. It's the summation k 0 to n choose k, p to the k, 1 minus p to the n minus k. I recognize this as the binomial, as the expansion formula for p plus 1 over p to the power of n, which is just 1 to the n. Agreed? So again, I just verified the answer is 1. So let's see this example. Screws produced by a certain manufacturer are defective with probability of 0.01, independently of each other. In other words, 1 out of 100 screws is defective independently. And the company is selling those screws in batches of 10 and offers money back guarantee that at most 1 of 10 screws are defective. what is the probability that a package must be replaced? Okay, so you see, you either can have 0 defective screws or 1 defective screw. Otherwise, you have to replace. Okay, so the question is, what's the probability that you have to replace a package? So the probability you have to replace the package, let's say here I say, let's say X be the number of defective screws. I have to replace the package if X is bigger than or equal to 2. Which is the same as 1 minus the probability that X is less than or equal to 1, which means it's 1 minus the probability that X is 1, and also minus the probability that I have 0 defective screws. And so the number of packages, once I just calculate it, the number of packages that have to be replaced is roughly 4 out of every 1,000. You see, 0.004. So roughly 4 out of every 1,000 packages will have to be replaced by this company. All right, this one is maybe a little bit more interesting. At each step, a randomly moving particle is equally likely to move 1 unit to the left or 1 unit to the right on a number line. If the particle executes a total of n moves, describe the probability mass function for the particle's new position given that it starts at 0. Do you understand what I mean, guys? So you have a random particle moving left or right. Random meaning it's equally likely to do that. What is the probability that it will be in whatever position possible? Okay, that's what we are trying to find out. So how to do that? Well, so we can describe X to be the number of right moves. How many right moves do we execute? So the position of the particle is going to be the number of right moves. Basically, total number of moves is n. Do you agree, guys? So if X is the number of right moves, the number of left moves is n minus X. So we are interested in what values can be taken by the function n. Well, so by the function, let's just erase this. By the function x minus n minus x. You agree? Because my final position is exactly the number of right moves minus the number of left moves. Do you agree? Right, if I move left, I move back, right? So for example, at 0, let's say I can, doesn't matter in which order I execute it. So I am interested in this, look at it. So what is this? This is simply 2x minus n. That's my random variable, where x is binomially distributed, right? The number of right moves, I can consider it a success if I move to the right. So x is binomial random variable, so you can write the binomial with parameters n and 1/2. N is the number of trials, 1/2 is probability of success. Yeah, of course. Which part? So here I am interested in, you understand what's probability mass function, guys? Yes, probability mass function is what outcomes can happen when I play this game. The particle can either be staying at the same location or moved somewhere. Now it only had n moves, and each move was executed randomly, either to the left or to the right. You understand? So it's an integer position. Either I'm at 0 position, or can I be at position 1 or 2 or 3 or 4 or 5 and onwards, right? That depends on how many moves I have to execute, of course, and how many left-right moves I have. Yes? So how to describe those positions and the probability of being at those positions is what I'm interested in. Now I decide to pick x to be the number of right moves. Do you agree? X is the number of right moves executed. So x, the total number of moves to the right, is binomially distributed with parameters n and 1/2. This means the number of trials. This means the probability of success, where success here means movement to the right. So far clear? Now, I am not interested in x, I am interested in my position. Now, what's my position? My position is the number of right moves minus the number of left moves, right? Each time I move to the left, I move to the negative x-axis, so I subtract. So I either executed right or left moves. Good. So this is the formula, guys. So the formula for my random variable is 2x minus n. Do you agree? Why the position I can attain is always 2x minus n. Why is that the case? Because the number of right moves is x. Subtract from it, the remaining moves were left. So what is the left moves? It's n minus x, right? If x from 0 all the way to n are my right moves, then n minus x, the remaining ones are my left moves. The reason I subtract is because left moves mean subtract, move to the left, and right moves mean move to the right. And I obtain, this is my random variable y, I obtain 2x minus n. That's my random variable. So what are the possibilities? If x is equal to 0, you can see x equal to 0 means I'm only moving to the left. So then I'm at minus n. That works, right? If x is equal to n, that means that I'm only moving to the right. So I have 2n minus n, I get n, right? That's possible. Good. So those are the values that I can take. And in particular, 2x minus n is equal to k. In other words, let's say k is some value that can be taken. That implies that x is equal to, just solve this equation, to n plus k divided by 2. So, the position that can be taken must be so that when you add n to it and divide by 2, this number is divisible by 2. N plus k must be an even number, which means, look at it. So the possibilities are for y that it's equal to minus n, then minus n plus 2, then minus n plus 4, and so on and so forth, right? Because, well, x is, look at it, just shift the x. What are the possibilities? X is 0, it's minus n. X is 1, it's 2 minus n. X is 2, it's 4 minus n. So you can see those are the positions available for me. You agree? Because x, the number of right moves, is either 0 or 1 or 2 or 3 or all the way to n. So you can see that you just multiply by 2, the addition here. So it's minus n and plus an even number. Those are the positions possible. Agreed? It's just minus n plus an even number. That's because number of right moves is multiplied by 2 here. So what's the probability that y is equal to minus n plus 2j? That's the same as the probability that x is equal to j, which means I executed j right moves, which is n choose j times 1/2 to the power of j times 1/2 to the power of n minus j. So altogether it's just 1/2 to the n. Good? You understand how I obtained that formula? So because we have a fully random motion, if they were not equal, then we can make that adjustment easily, right? So because it's fully random motion, that means that the probability that I'm at location minus n plus j, where j is bigger than 0 and less than or equal to n, is simply n choose j 1/2 to the n. Wonderful. So I think, guys, since the class is coming to an end, the next question will be too involved to discuss today. Although I would be happy to, but why not? Let's call it, yeah, I understand you're sad. So if you want to stay, ask me questions about expected value, variance, covariance, Covariance. Yes? Then stay with me. And if not, then take care, guys. Goodbye.